this video, the students will discuss about case study on wind turbine power plant. In this video, the students will discuss about how the wind energy is formed, how the electricity is produced from the windmill, what are the components of the windmill, what are the working principles behind the windmill, and what are the different types of windmill, and finally the advantages and disadvantages.
Okay, let's discuss about the introduction of the wind. Wind is defined as an atmospheric air in motion, and it becomes an energy source. Then the sun produces 4 into 10 power 26 joule of electromagnetic radiations every second in the space. Then about 2% of sunlight that falls on the earth is transformed into wind energy. The sunlight which falls on the earth which transforms into wind energy, and wind provides around 1% of the world's electricity, which is an energy source. Then the process of wind creation. Wind is produced by the difference in the atmospheric pressure. When a difference in the atmospheric pressure exists, air moves from the higher to lower pressure area, resulting in winds to various speed, which means the difference between the atmospheric pressure from the hot to lower pressure. Two major driving factors of wind patterns are like the rotation of the planet and such etc. And then next we will discuss about wind.
So now I will be explaining the types of wind turbines. First I will be explaining the wind turbine. What is wind turbine? Wind turbine is a rotating machine that can be able to generate electricity from kinetic power of the wind. It is similar to an aircraft propeller. It turns into a moving air. Wind rotates the turbine blades, spins a shaft connected to a generator. The shaft will be connected to a generator, and the wind energy pushes the turbine blades, which produces kinetic energy, and it is converted into electrical energy. The efficiency depends on the windmill increases based on the number of blades. There are 3 types of blades. The first type is one blade consists of a single blade. The rotor moves more rapidly because the weight is reduced, and the gearbox ratio is also reduced, and ultimately it provides no cost savings. The second type is rotor must move more rapidly. Higher speed means noise and other impacts, need sharp observers, and captures 5% less energy than 3-blade design. Next, the third type is the 3-blade design. Balances of gyroscopic forces, slower rotation, and increases gearbox and transmission cost, more aesthetic and less noise, and fewer bird strikes. These are the 3 types of blades. And next will be explained by.
So there are 2 types of wind turbines. First type is vertical axis, and second type is horizontal axis. So in vertical axis turbines, the rotational axis of the wind turbine is vertical and perpendicular to the rotor. So in horizontal axis, the rotation axis of the wind turbine is horizontal or parallel to the rotor. Okay, and next, primarily used in wind projects and residential applications. Horizontal wind axis primarily used in big wind applications. Okay, and vertical axis powered by wind coming from all 360 degree, no yaw mechanism. And horizontal axis able to produce more electricity from a given amount of wind. Okay, so the next will be explained by Govind.
So I am going to discuss about the working principle of the windmill. Working principle: the energy in the wind turns 2 or 3 blades around the rotor. The rotor is connected to the main shaft, which spins the generator to create electricity. Wind turbines convert kinetic energy in the wind into mechanical power. There are several parts in the windmill. First one is blades, which converts the kinetic energy into rotational energy. Next one is gearbox. The gearbox speeds up the rotational energy to create more power. Next one is brakes. Brakes limits the speed of the gearbox. Generator generates the mechanical energy into electrical energy. Yeah. Drives the yaw drive.
dioxide emissions compared to other energy production methods, and no air or water pollution, and no environmental impacts for mining and drilling. Completely sustainable, unlike fossil fuels, and wind will never run out because it is sustainable. And turbines work almost everywhere in the world wherever the wind is produced, and reliable, and freedom, and prices are more lesser to produce than other methods. And disadvantages. The disadvantages are high upfront cost. There are more costs to build and constructions and maintenance, extra cost for complexity and balancing variable ratio, and damage local wildlife, and large overall land. Though 95% of the land forms are being occupied, can't supply 100% of the country's power. It is an sub energy producing method, and loss of jobs for people working in mining and drilling. These are the advantages and disadvantages of the